we know how to do the derivatives of trig functions. Don't forget your math homework. But not inverse trig functions.
How are we supposed to survive in class without Connor telling us hello class every day?
Yeah, no, I'm not going to survive.
We'll make it, I promise. Since I don't know the formula for the derivative of inverse sine yet, we are going to rewrite this problem. Okay, so what this means, remember, inverses, if you want to rewrite it in terms of sine, this means sine of y is equal to x. Remember, to move a trig function away from its angle, you do the inverse. So to undo that, if I want to move the sine back, the inverse goes away.
I remember talking about this because I remember we thought about it like a log.
Yeah. So basically, when I'm taking away that inverse, if I want to move just this to the other side, the inverse symbol goes away. Now it's regular sine. Okay. What's the derivative of sine? When you do the derivative of a trig function, angle stays the same times derivative of the inside. What's the derivative of y? Equals derivative of x is 1. So that means dy dx
It's secant.
is 1 over cosine of y. However, I am trying to derive some of these formulas. So actually all the derivatives of inverse trig functions have lovely formulas, and I'm going to show you a table in your book that has them. I'm not going to make you memorize them. It's not something we use a lot, but I can't just skip it because if you go on and have to take further calc, it will come back. So I want you to have seen it before. This has a y in it. If I want to write it in terms of x, we have to think back. When we talked about inverses in trig, okay, when I see this statement, y is my angle. Okay, sine is SOHCAHTOA, opposite over hypotenuse, right? So my opposite side would be x, my hypotenuse is 1. You guys with me so far? So if I wanted to find the third side in that triangle, what would we do?
Pythagoras.
If I want to figure out this one.
Oh,
Tangent?
oh yeah, no, it would be yeah, tangent.
Yeah.
You're a genius. Oh, never mind.
Okay. So we're dealing with first quadrant, so this would be a positive, so a is just the square root of 1 minus x squared.
Is it plus and but it can't be negative.
So sine inverse, if you remember back in trig, exists in quadrants 1 and 4. Both of those it would be positive. Okay. So now, if I wanted to simplify my dy dx, it's 1 over the cosine of y, then I could look at this picture. Cosine is what?
Opposite
One
over
x.
x.
Adjacent over hypotenuse.
Wait, x over.
So
Adjacent
Oh.
over what?
this over 1.
So just that.
Oh no.
I can't think of what adjacent and opposite are.
So adjacent is touching. Opposite is not. Adjacent is touching my angle, but not the hypotenuse. So we know this is the hypotenuse because it's across from my right angle. Opposite is across.
Okay.
Adjacent is touching.
Mini trig lesson.
All right. So this is actually a formula.
It's in our book. I'm looking.
You could, but usually you're using this when you're doing derivatives, and it would be much easier to do a derivative of that versus the other when you have to do quotient rule. So you could definitely move it, but you don't have to in this. We're really just deriving a couple formulas right now.
So you don't want us using the 1 over cosine or like secant or anything. You want us using
I mean, you could change it. Like, yes, there are different ways you could simplify it. So if you said this is secant, then when you go to your picture,
It would just
secant of
radical.
y is hypotenuse over adjacent, and it gives you the same thing.
But I was
Adjacent
saying
over
you want us to go to,
You want us to give it like an actual value?
I want you to give it to me in terms of x. We are, right now I'm deriving these formulas that we're going to use in our derivatives. Okay. I'm going to derive another one for you. We are going to do tangent. Because I think I might have left one for you to figure out. I think cosine I left as a homework problem. So, we're going to do the same thing and find the formula for the derivative of inverse tangent. Okay? So this is kind of like a proof. Not how you would do every problem, but this is where these rules come from that I'm about to give you in a second. So if I wanted to do this, I would have to rewrite it. So that means tangent of y is equal to x. So if I do the derivative of tangent, do derivative of trig function, angle stays the same, times derivative of the inside equals, so dy dx is 1 over secant squared y. Okay, but my final answer is with x's, not y's. So we come and think about our picture. Tangent inverse also exists in 1 or 4, so it looks like we'll just go with quadrant 1. Tangent of y is equal to x. So my angle is y. Tangent opposite over adjacent. Okay, so now this time I have to find a squared plus b squared equals c squared. Square root of x squared plus 1 or 1 plus x squared.
Why did we get our x from? We drew it on the triangle. It's just y is, okay.
From my definition of tangent, SOHCAHTOA. So tangent of angle y is x over 1. So
Okay.
opposite over adjacent.
Okay, thank you.
You're welcome. Other questions? So once I have my triangle, we can simplify. 1 over secant squared. So secant means hypotenuse over adjacent.
X squared, radical x squared plus
So we just get radical x squared plus 1 over 1, or radical x squared plus 1. And if you square that, it's 1 over x squared plus 1. I want you to get your book and turn to page 214.
It's kind of, I'm one of those people that works backwards.
I'd like to know what the answer is.
Sometimes, like I looked at that and I couldn't,
it's only.
I just forgot it's squared. So I forgot how it, I couldn't figure out how it got to know the square root, where the square root went to.
Gotcha.
Do you like a square root?
What am I
I haven't opened it yet because I don't feel very well, but I would like if you want to feel like a square root. No, I've actually been sick for the last 4 weeks. But Dr. Euchre just got back from vacation today. So, you know.
All right, so page 214, the bottom of that has the formulas. These are the derivatives of the inverse trig functions. Okay, all of them given to you. I am not going to require you to memorize these. Okay, I am also probably not going to put these on a test since I'm not making you memorize them. I'm not going to test you over them. But I didn't want to just skip it because that wouldn't be fair for people that have to take more calc later on. They do sometimes come back into play. Okay, so I can't just skip over them. You can use these formulas. I think one homework question has you derive the formula for cosine, which I've already done sine and tangent, so you should be able to do cosine very similar. Now we're just going to do a couple problems on how to use these formulas, and then we'll be done, and the rest of the time is for you to work.
The cosine negative again.
So, if I ask you to find the derivative of y equals 1 over sine inverse of x. If it's written like this, to do the derivative, I would have to do a quotient rule. We could also write it as a -1 power. Would you guys be okay with that?
Yeah.
So this is the same thing as saying sine inverse of x
Oh.
to the -1 power. Alright, so let's do our derivative. Derivative of y is
dxy or dy dx.
y dx. Derivative of y in terms of x. Equals, okay, chain rule. Exponent comes down. Inside stays the same. Subtract 1 from the power. Times derivative of the inside. But
We have our
we now have our table. What is the derivative of sine inverse of x?
1 over 1 or square root of 1 minus x squared.
Yeah. As far as simplifying this, not really a ton you could do. You could, if you wanted, it's a -1. A -2 power would put this on the bottom if you wanted to.
but you're not requiring that.
I would not count off if you didn't. But even so, that's really all the simplifying we can do. Questions on
Let's get to cooking.
let's look at. So if I did x arctangent square root of x. Okay. Arctangent is just another name for
Tangent inverse.
tangent inverse of a square root of x. That's like x to the 1/2 power. So you notice my angle is different this time. So if we do our derivative of f, we can call it f prime if we wanted. What am I going to have to do here?
Product rule.
Product. Okay. Derivative of the first. Derivative of x is 1 times the second. Plus the first, so x, times derivative of the second. All right. The formula for tangent inverse, the derivative of tangent inverse is what?
1 over 1 plus x squared.
Here's the confusing part. X in the formula is your angle. This time my angle isn't just an x.
X to the 1/2 squared.
So it's x to the 1/2 squared.
Oh,
Okay, and then since my angle isn't just a plain x, we have to do chain rule. So times, what's the derivative of x to the 1/2?
1/2 x to -1/2.
no. Does the f prime x not switch out with an x?
Prime x?
That just means the derivative.
That's
Like
just-
f of x,
I'm just
it's just in
confused.
function notation.
Yeah.
Tangent inverse of x to the 1/2 plus, okay, if I take x times 1/2 x to the -1/2, that gives me 1/2 x to the 1/2.
And that just gives you 1 plus 1 over x, right? You add exponents when you multiply.
With
No.
power to the power, we multiply them.
No, I mean with the other x's.
Yes, we
Okay.
add the 1 and the 1, -1/2. Yeah. here, 1/2, x to 1/2 squared is just x. So really, all we could do to finish this inverse x to the 1/2 plus, if we wanted, we could make one big fraction here. We have an x to the 1/2 on the bottom 2 times 1 plus x. And that's about as nice as this one's going to get. Alright, so in those formulas, the x is just representing the angle. So if your angle is not a plane x, you are setting in whatever that angle is equal to. I would like to look at problem number 17 together from your homework.
Not upset.
Is this problem gonna require more than 4 lines of notebook paper?
Highly likely.
Okay, so I'm gonna flip to the next page.
Okay. So on that homework, we are going to do problem 17 together. If you can do it out of order, just make sure it's clearly labeled. All right. So we have tangent inverse So if I go through and I do the derivative, we have the derivative of tangent inverse. So we now have a formula for that. Look at the bottom of page 214, the formula for the derivative of tangent inverse.
1/1
plus x
plus
squared.
x, or plus the angle squared.
Yes, x is representing the angle. So my angle here is x squared y. Okay, but because my angle is not just x,
Yeah, practical.
chain rule.
I mean, yeah, that one.
Chain
So within the chain rule, we have to do the product rule. This one is beautiful.
Oh, I didn't skip to the next line, so I'm working on half a line of paper.
Derivative of the inside. So right now, I'm doing the derivative of x squared y. So derivative of the first
2x squared dx.
times the second plus the first derivative of the second, derivative of y is y dx. So what's wrong, Grant?
Would you bring down that 2 for the square?
It's product rule. Derivative of the first one, so derivative of the x squared.
Yeah.
So we're just doing the derivative of whatever's inside of parentheses, not the fact that it's squared. Like, since it has.
Not the fact that it's squared.
Because he's looking at the fraction.
Oh, this mess right here is the derivative of the tangent inverse.
I like
So-
how you talked about it.
We do the derivative of the outside. Derivative of tangent inverse gave us that. Times derivative of the inside, which is that.
Why would we
This
do product rule on that though?
Because it's not tangent times this, it's
No,
tangent
of.
of that. Okay, moving to the left-hand side, derivative of x.
1.
That was nice. All right, now, we need the derivative of xy squared, so we have to do
Product rule and then chain rule.
the first, derivative of the first times the second, plus the first times derivative of the second, derivative of y squared is 2y dy dx.
Yeah, I ran out of room a little bit on this line.
Okay, take a second, digest that before I move on.
Digest.
Digest.
Oh, it's
Digest.
digested.
Um,
It's all digested.
I'm gonna rewrite this on a line that makes sense.
do we always
Why call me
multiply
back?
by whatever tangent of, or like whatever the,
It's just a chain rule. If the inside isn't a plane x, you have to do derivative of the inside.
okay, so it's just whatever on the outside, if it's more than x, it's just you multiply the derivative of the outside and the inside, okay.
Alright. Now, we would like to clean this up somehow, wouldn't we?
Yes, please.
It's a little bit.
Just a little bit. Okay. So this will give me 1 over 1 plus x to the 4th y squared times, and here I have 2xy plus x squared dy dx.
Let's get those dy dx.
Can I go ahead and distribute before I do that?
Sure.
Oh, distribute.
Sure.
That's how you. do
Wait,
it.
why can't we just put all of that over one?
Oh, I get it.
Well, you
We
can't,
have to
order of
break it
operations, this is multiplied, I have to,
Yeah.
I can't start subtracting terms the other side.
I mean, like, why can't we put all of that over the denominator?
You can,
Yeah,
but then we have to
split it.
get this dy dx part away.
I should have skipped a couple more lines.
Okay. Not very pretty at all. Maybe worse than usual. Yes.
Could you just have it all like, wait a minute.
That's what I asked.
Oh, I do.
Oh, but how are we gonna get the denominator?
Alright, so I need these on one side because they have dy dx. The rest of it goes to the other side because they don't. Okay? So, I'm gonna say.
That floor cleaner is so creepy sounding.
Do problems like these doing them, like, right in the beginning? I mean, like, I know you know the answer, but like, do they get your gears turning when you're doing them?
Yeah,
Or is
because
this
I
just-
also don't have the answer.
or is
You
this
want
just-
my answer key book? It's the same as your book.
It's our book that
Oh.
says teacher copy.
Yeah,
Oh.
it's the only difference. It says teacher edition,
Oh.
Yeah.
but it's not.
But is this like light work for you, or are you like?
Is this easy?
I mean,
Like,
there's definitely thought
Or are you
involved.
like-
is this your warm up set?
What would we do now?
One of them.
Take out
Multiply.
that-
Oh,
Take out
no,
that
you're right.
dy dx.
Would you guys be like totally upset with me if I just erased it and wrote it out here?
That's fine.
Nope,
We
that's
just have
perfectly fine.
If I just like cheated?
Yeah, let's get that
I
out of
can't
there.
cheat.
You can.
No, I need to know what I'm doing or I'll never know
I
again.
never know what's going on. Wait a minute.
Let me go insane.
Oh, I got a parenthesis sheet.
Oh, isn't this fun? This is the problem that keeps on giving.
It really, it
Dude,
truly is.
yeah,
You
'cause
were
I
really in
have
the
zero.
Christmas mood right
Well,
now.
I'm doing it with you, but it's so much fun. I didn't want to not do it.
Well, I'm just glad you are. I'm glad you like us enough
I
to.
got this much room left, too busy.
This is gonna take up a whole page.
He has a line.
I've been doing it all right here.
You're not even doing it in your homework? Oh, okay.
No, I started a fresh page.
I started a fresh page. I'm almost halfway down.
What?
Wait, what?
What are you
Halfway
doing?
down is cool.
Okay, that's because your math is completely.
Right,
It is not.
colossally large.
This is going. A fraction takes 2 lines. You realize it's being burned at the stake right now. Gee. Take me off the burner and put me
Wait,
on
wait,
the
wait,
simmer.
Mr. Go, hang
Kinda
on
sort of fun
before,
fraction.
hang on, wait, I gotta write this.
I'm trying.
Do you want us to simplify? Oh wait, we just multiplied.
Hang on.
Yes.
Hang on, wait.
Hang on.
I understand.
Stop
the
having
lines.
euphemisms.
No more epiphany.
That's not the word I want.
Epiphany.
Yes,
Euphemism?
thank you. I'm glad you used what I
Why
was.
would I stop having a euphemism?
I don't know, but so you better stop.
Stop.
I never want to hear that voice again.
Okay.
Why is this the same?
So,
This is a long
we are
one.
close. The final thing is really just notation. We do not like to leave a fraction in a fraction. So, to fix it, I'm going to take everything times 1 plus x to the 4th y squared. Alright, so
Wait, is it just, oh,
when?
it was never 1 plus x to the 4th plus y squared?
No, never multiply.
Oh wait, no, I somehow added that in, wait.
You can make a spoil.
So, if I'm taking 1 times this, distribute the 1. So,
Oh, and we
1
can't take anything out. 'cause it's
plus x to the 4th y squared. So I took my 1 times both terms. Now I take my y squared times both. So y squared times 1 is y squared. Y squared times x to the 4th y squared is x to the 4th y to the 4th. Minus, in the last term there's no negative cancels, and I just get 2xy.
I fit it all in, Grayson.
I didn't foil out. I didn't foil out, so I owned myself.
Oh no,
Dude,
what,
what?
how did this happen?
Yeah. It's not gonna.
Why do you look like you're
simplify past
contemplating
this.
life right now, Mr. Gold? Are you?
Cause it's x squared. Difference of
Oh,
squares,
no.
yes.
Wait,
We all
Miss
about
Freckle,
Nothing. I'm just.
I might have a semi-major problem. So somehow I ended up all positive,
I will
instead of all negative.
look at it in a minute.
We're all negative. What?
Okay.
Yeah.
I'm going to go ahead and finish this, so you guys can stop your talking for a second and just listen to me, because you've been talking over me for like the last 10 minutes and I'm getting annoyed. You talk over everything I'm saying and then you're confused because you didn't hear anything I said. I am distributing right now. So, what I just did right here, I took my 1 times 1. I took my 1 times x to the 4th y squared. That's where I got those terms. Then I took my y squared times 1, and my y squared times x squared, y squared. That's where I got those terms. Then I multiplied these, but the denominators cancel. So that's where I got that term. Now we're going to do the same thing on the bottom. So, if I take this times that, they're the same. Denominators cancel and I just get the x squared. Take my negative 2xy. So negative 2xy times 1 is negative 2xy. Negative 2xy times x to the 4th y squared is negative 2 x to the 5th y cubed, because I'm adding my exponents. And at this point, we're done. So, definitely a nastier problem, and I did not give you any like this to do on your own. If your signs are off, or you don't have the same numbers, please